Hello, math students, and welcome back to our module on statistics and probability. This is lesson 4, and it is called Chance Experiments and How to Model Them. Our goal for today we will learn how to model the outcomes of events. The question that I want you to think about during the lesson is, how can you keep track of the probability of multiple experiments at once? All right, so some things to know. Now that we know how to determine the probability of an event, we need to practice a way to keep track of all the data. There are many times when you will be asked to determine the probability of many events happening during one experiment. An example of this is every morning when I get dressed, I must decide what to wear. I go to my closet and I look at my choices. I look at 4 different shirts and 4 different pairs of pants. What are all the possible combinations of the shirts and pants? So right there is an example of needing a way to keep track of the different variations that will happen if I choose a shirt. What would be the outcome of the 4 different pairs of pants? Then if I choose a different shirt, what would be the outcome with pairing them with the 4 different pants? And so on. So you can see there's a lot of different outfit combinations that could exist, and we need a way to organize them. So we need a way to organize the choices to keep track of the combinations. A model that we use to do this is called a tree diagram. And a tree diagram organizes each shirt and each pair of pants combined to make an outfit. And so this is what a tree diagram looks like. So typically what you do is you start off with what you have. So for example, I am the person. So I would say that here I am, this is me, okay? And then I get to start from my shirt choices. So I'm going to say my first thing is my shirt choices. Then my second thing that I have to work through would be my pants choices. And then the last thing that I have to keep track of is the outcomes that happen with that. Okay, and so that's how we would set it up so that we have everything organized. So we're going to say I have shirt 1, right? So I'm going to say SH1 for shirt 1. Then I have shirt 2. Then I have shirt 3. And then I have shirt 4. And what that is going to do is that's going to say, okay, if I choose shirt 1, then I know that I also have 4 choices of the pants. And so I'm going from me to choosing shirt 1. And then from shirt 1, I have the option of pants 1, pants 2, pants 3, or pants 4. And I have that one shirt could be combined with all of those pants. And so I go from there to there to there to there. So you can see that I have quite a few possible choices. Then I do the same thing and I go to shirt 2. And once again, for the shirt 2, I also have pants 1, pants 2, pants 3, and pants 4. So then from shirt 2, I have the options of doing shirt 2 with pants 1, pants 2, pants 3, or pants 4. Okay, then I also have the option to choose shirt 3. And if you're starting to see the pattern, the next pattern that we have is, okay, I choose shirt 3, but then I also have the option to choose pants 1, pants 2, pants 3, sorry about that, and pants 4 for that shirt. So again, I have 4 choices that I can get from that combination, okay? And then, if you're paying attention, I have one more shirt choice that I can go, and again, with shirt 4, I also have, because I ran out of room and I didn't plan this very well, I have pants 1, I have pants 2, I have pants 3, and I have pants 4 if I choose shirt 4. So there's 4 more possible choices that I can make, okay? So then, from there, what I have is I have to write down, or I have to list all of my possible choices that I'm going to make. And so if I'm listing all of those possible choices that I can make, those are called the outcomes. And so what I have to do is I have to list the outcomes to figure out what I am doing as the result of those combinations. And so there is a way to list the outcomes, and what you do for listing the outcomes is you take each combination and you write it together and you list it in the outcomes category. So for example, on this one, I would say my first choice was shirt 1. So let's actually shorten it to S1 for shirt 1. And pants 1 was my first outcome. Does everybody see that? Then I have shirt 1 again, and I have pants 2. And then I have shirt 1 again, and I have pants 3. And then I have shirt 1 again, and I have pants 4. So those are the outcomes that you would see, okay? Then we have to do that for each shirt. So then we have to do shirt 2 with pants 1, shirt 3 with pants. Again, those are all possible outcomes. And then finally, we're almost finished with listing our outcomes. Now we have to do shirt 4 with pants 1, shirt 4 with pants 2, shirt 4 with pants 3, and shirt 4 with pants 4. And now we are able to see, so we have quite a few combinations, and all of these combinations are different because none of them are exactly identical. So they all count as a different combination, and if you add up the combinations, you would see I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. I have 16 total outcomes, so my denominator would be 16. And then I ask you the question, what is the probability of wearing shirt 1 with pants 1? Well, if I find shirt 1 with pants 1, that only happens one time, so I would have 1/16 of a chance to wear shirt 1 and pants 1. And actually, that's going to be the case for all of your outcomes because each outcome that you see does not repeat ever. And so the probability for each one of these choices is that I have a 1/16 chance to have this combination. Now, there's a way that we can shorten this process by not having to actually draw each branch, although it's a very good way to begin learning how to do this is by drawing each branch, because then you can visually see what the outcomes would be. But we can also use probability to help us figure this out, because how many total shirts do I have? Okay, so for my shirt choices, my total shirts that I have are 4, so that would be my denominator, right? And then out of my 4 shirts, how many 1 shirts do I have? I only have 1. So that means that I have 1/4 of the probability for this shirt. And that's true for each shirt because shirt 2 is different than shirt 1, so that's still 1/4 chance. Shirt 3 is a different shirt, so that would still be a 1/4 chance. Shirt 4 is a different shirt, so that's still 1/4 chance. And what we know about shirts is they are all shirts. They don't have the shirt with the right arm missing. Okay, remember we talked about in the last lesson of not equally likely? Well, this one doesn't have anything to do with not equally likely because a shirt, in order for it to be a real shirt, it has to be the shirt. You can't be missing the right arm and it still be a shirt. So again, this would definitely be a 1/4 chance. And the same goes for my pant choices because I only have 4 pairs of pants that I'm looking at. And so in order to get my first pair of pants, that would be a 1/4 chance, right? And then in order to wear pants 2, it would be a 1/4 chance. To wear pants 3, that's a 1/4 chance. And to wear pants 4, that's a 1/4 chance. Well, if you notice something, when I choose that shirt, whichever one I choose, which is 1/4 chance, and I choose that pair of pants, which is again a 1/4 chance, if you look at these, what would be the outcome of getting shirt 1 and pant 1? It would be a 1/16 chance because you multiply your shirt probability by your pants probability, and you get 1 times 1 is 1, and 4 times 4 is 16. So it's pretty awesome. This is the long way of determining all of your outcomes. And then when does each one happen? Only once. or you can use what you've learned about probability. There are 4 total shirts. Shirt 1 is itself, shirt 2 is itself, shirt 3 is itself, shirt 4 is itself. So the probability of choosing shirt 3 will happen 1 out of 4 times. The probability of using pants 3 will happen 1 out of 4 times. So then you just multiply straight across and you will get that outcome of shirt 3 and pants 3. It only happens once. Okay? So, that's a lot to remember, but that's what tree diagrams are. Okay? So again, a tree diagram organizes your events that you have, and then it helps you combine them to make what the total outcome would represent. Okay? So it's kind of fun. It's for a lot of you, you're going to be like, wow, that's a lot of work. And I do actually want you to make the trees at least 1 or 2 times because I want you to familiar with the idea of how to make the trees, and then you can go and use the probability and check yourself to make sure you got it right. Okay, so let's do some more information searching really quick. The next page says, so tree diagrams are an important way of organizing and visualizing the outcomes. That's absolutely true. By looking at these actual tree diagrams, it helps you make sense of collecting all the data, so that's nice. A tree diagram is a particularly useful device when the experiment can be thought of as occurring in stages. So an example of what they mean by occurring in stages would be, what if you did an experiment of the number of spoons of sugar that you put in your beverage throughout the day. So in the morning, if you drink tea and you put 3 spoons of sugar in your tea, then you would have to record the probability of that. Then what happens when you're recording the number of spoons of sugar that you put in your iced tea at lunch, and then let's say what would be the number of times you put sugar in your, let's say you drink coffee at night. Okay, so that's reoccurring stages. And I don't drink coffee, so I understand if you don't. But that was just an example that I could think of that happens in stages. Okay, it happened in the morning, then it happened in the afternoon or lunchtime, and then it happened again in the evening or at nighttime. So those would be the stages. And so you're trying to figure out what was the probability in the morning, what would be the probability at lunchtime, and what would be the probability at dinner time. And then you would use that information to combine and figure out what the total probability of the combinations would be. So that's what it means when it says the tree diagram is a particularly useful device when the experiment can be thought of as occurring in stages. Tree diagrams are also useful for computing probabilities of events with more than one outcome. That is totally my outfit. There's way more than one outcome, because I have 4 different shirts and I have 4 different pants, and we have 16 different outcomes. So the tree diagram is very, very helpful for computing all those probabilities because we can see them. Okay? All right. So in order to solidify your knowledge on tree diagrams, I'm going to have you try one. So it says, imagine a family of 3, Alice, Bill, and Chester, plays bingo at home every night. Each night, the chance that any one of the 3 players will win is a 1 in 3 chance. Why is it a 1 in 3 chance? Because there's 3 players, and Alice could win one night, Bill could win one night, or Chester could win one night, because there's 3 players, and each player has a chance to win. So the probability of them winning would be a 1 in 3 chance. Okay, hopefully that makes sense to you. All right, so now the next step that it asks you to do is it says, using A for Alice, B for Bill, and C for Chester, develop a tree diagram that shows the 9 possible outcomes for 2 consecutive nights of playing with each person winning. Okay, so we would have if Alice won, if Bill won, if Chester won. Okay, so on the first night, I'm going to help you get started. Let's say that Alice won. Okay, so that would be the first night. Or you would say that Bill won. Okay, or you would say that Chester won. And so what you're trying to do with this is you are trying to show all of the 9 possible outcomes, right? I think that's what it said. The 9 possible outcomes of 2 consecutive nights of playing, right? That's what it's saying that you need to do. So if we take a look at it, I would like you to think about how you are going to create a tree diagram to show those outcomes. That's your job. That's what you're supposed to be figuring out. And so we would list the possible winners. So I helped you start off. So if Alice won, okay, then you need to do one if Bill won the first night, and then you have to do one if Chester won the first night, okay? So these are your different options that happened the first night. If Alice won, okay, then Chester could win. It says, and those combinations could win. Look like that. Alice won do the whole thing for outcome. Alice, answer this question. What is that point? Okay, you have Alice win. I will be very other. Okay, so it's kind of fun. The tree diagram is really, really helpful. It helps you organize your information. It helps you see what's going on. Is it a lot of work? No, but does it take a lot of space? Yes. So you have to have quite a bit of room to spread out and have all of your choices, but it really is a nice visual way in order to see what's going on. Okay, I know this is a long one, but I think it's really helpful and it has a lot of good information. So going back to our goal, today we will learn how to model the outcomes of events. Ta-da! We did that with the tree diagram. Our question was, how can you keep track of the probability of multiple experiments at once? The best way to keep track of them is to draw a model. And the first model that you're learning about is a tree diagram. So there you go. All right, kiddos, that's all I have for you today. I hope you're enjoying this little fun time we're having with probability, and I'll see you all tomorrow. Okay, see ya. Bye.